Hi, everybody, and welcome to Lab 6 for Physics 1105. Okay, so let's take a look at Lab 6's manual. This is the Newton's Law lab. So here's the manual. Oops, I should have gone back to here. Here we go. So here's the manual. Okay, so we'll look at the experiment. Now, this experiment uses a simulator. So let's take a look at the simulator and just figure out what to do. All right. So here's the simulator. And in the lab manual, it says you need Java installed. You don't, because there's a version of this that just runs right in your browser. So it should be fine. Okay, so what do we do? So here's what we're interested in doing. We're interested in having this little robot guy push this file cabinet with a particular amount of force. And then we want to find the acceleration by looking at a position versus time graph. Okay, so let's just do a run here. So what I'm going to do is I'm going to start with 10 newtons applied force. I'm going to make sure that the friction over here is off. So make sure that's off. You should also write down the mass of the file cabinet that we're going to be pushing. You're going to need that later. All right, so, and then I want to graph position, okay? I'm not gonna graph everything else, I'm gonna graph position. And I'm gonna push go, and now it doesn't really run in real time. Like these are seconds down here. I don't know, this is time, but it's right on top of things. It's in seconds, but it doesn't run in real time. You'll see what I mean, like seconds, I don't think they're really going in actual seconds. But let's just let it go. And I'm going to let it go till it really gets to the house. Okay, so here we go, and let's watch it together. As you can see, time moves very slowly here. Here is the position starting to change. It's probably going at about a second, real seconds. It's hard to tell. Okay. And I'm just going to keep it going. I'm going to push the pause once it gets to the house. I'm actually push it before that because when it gets to the end of this, it's probably enough, but let's just let it go. Okay. Let's let it go till it gets to the house. As you can see, it's coming off the graph, but you can always zoom out a little. All right, let's pause. All right, now I'm going to get this. Hello, why can't I see this? Let me pause this for a minute. I'll figure this out. Okay, I figured it out. So instead of zooming in, what you can do is you can push this rewind button. And what that does is it just puts this cursor. This is actually a little cursor. It's this little purple thing. And it puts the cursor back here. So when it ran, the cursor was way, way over on the other side. And we don't need it to be. Okay, so why do I need this cursor? So what I'm going to do with this, and I'm going to open an Excel file. I'm not going to do this for you, okay? You can do this. And I'm going to record the time. So here I'll record, like, let's say you record right here at 2 seconds. It's at position negative 6.9 meters, right? And then you can go to 4 seconds and it's, negative 6.6, et cetera. I hope you get the point here, right? And you're going to do that, record a bunch of times. You can see maybe up to the point where it's off the screen, right? Up to 20. Okay. Now, when you go to Excel, you should be able to plot position versus time, and it'll look just like this, right? Now, when you fit, you're not going to fit a linear line here, right? This is not a linear function. As you should know from the kinematic equations for constant acceleration, position varies as time squared, right? So you're going to fit a parabola to this. All right. Now, when you fit a parabola, you should notice that the coefficient of x squared, remember how in Excel, it's always going to say x squared instead of t because it doesn't know your x axis is called t. The coefficient of that is going to be 1/2 times the acceleration. That's what you're after, okay? So what you can do is now find the acceleration for this applied force, okay? So now you did that in Excel, and you should have the acceleration and the force in a different 2 columns. So then you can make a different 2 columns. It says force 10 newtons and acceleration, whatever you just found from doing that parabolic fit. Okay. Now you're going to change the applied force and do it again. So do it 3 or 4 times. I think the manual says 5 times, but you want to be able to have several values of the force and several values of acceleration, because the next thing you're going to do is you're going to plot force versus acceleration, and the slope of that linear function will be the mass. Okay, and you can get the 90% confidence interval for that mass and compare it to the mass of the file cabinet. Okay, now I think the manual wants you to do this for another object too. So do it for 2 objects. I hope that was relatively clear. Please, if you don't know how to fit a parabolic function to a graph in Excel, please look that up on Google or text me or email me. So I hope that that's enough to get you started on this on lab 6.